Hello and welcome to F12 Programming. My name is Mike Hewitt.
I'm Jacob Rains.
And we're going to be talking about something really cool, read-only versus const, or a constant.
Yes.
Go ahead, take us away.
Well, I see these used wrong or interchangeably a lot.
And not just C#, a lot of different languages.
A lot of different languages.
And a lot of different languages kind of, yeah.
And I can understand absolutely why, because as an English speaker, read-only and constant mean the same thing.
Yes.
So I'm in one of our old solutions here from one of our other videos.
And while you're typing, this is a really good programming interview questions, I feel like.
Oh, absolutely.
I've seen it on every list of any kind of interview question you can imagine.
Yeah, and of course, I'll go ahead and give the spoiler alert now. They're different. They're quite a bit different. So let's make a class real fast that we can actually use for this. So I'm going to come over here and make a new item.
Oh, you should do it in the logic.
I should, but I wanted to keep this fairly simple. So I'm going to make this. I'm just going to call it sum class, and this is actually where we're going to do our work. And let's go ahead and make a public read-only. Let's just do an int for right now, and let's just call it value1. And let's do a public const int value2. And I'll show you what we'll do with these in just a second, but we're going to make a constructor. So let's go ahead and do a... Oh, you want to use your shortcuts?
Kotar, yep. There you go. Tap, tap.
Tap, tap. I never use those. It's always like a surprise. It's like, oh yeah, it does that. Okay, so the main difference between these, and we haven't really talked about static versus...
Oh yeah, I guess that's very important.
Static versus not static, I guess. What order do I want to explain this in? So let's talk about read-only first, because we don't have to really bring a whole lot into this. Amazingly, read-onlys can be written to, which is weird. So when I instantiate my class here, I can say value1 equals 1, 2, 3. And that is perfectly valid code. Matter of fact, and I can come down here later and I can say value1 equals 2, 3, 4. I can change my mind. And there's actually a few other places where I can change my mind.
Or even add to it, or plus plus.
Yeah, or add to it, or whatever I need to do. But after the constructor has finished, or technically speaking, very shortly after the constructor has finished, that read-only value is now locked in. But it's locked in for the instantiation of this class. And I'll show you what that means here in just a second. As a matter of fact, I'm in my constructor here. I'm going to go ahead and pass in, I'm just going to call it data. And I'm going to set this equal to, let's make this simple, data plus 100.
How I always remember it is a name. Because you're going to, some class could be a person, and that person was going to have that read-only name. That's probably never going to change.
Right. So
but go ahead. Yes.
That's exactly a good way of thinking about it. So you use this a lot for IDs and things like that. So back here on my program, I'm going to make sum class A equal to a new sum class, and we're going to pass it a value of 1. So I'm going to need another one of these.
B.
So I'm going to make another one. I'm going to call it B, and I'm going to pass it a value of 2.
There you go.
And now if we do, I'm just going to put a breakpoint because that's the easiest way to run this. I'm going to take this out. So here's my breakpoint. These have been created. And I don't think did I make that public? Yeah, I did. So if I hover over this, you can see that value1 is 101 for object A. And if I hover over B, we can see that it's 102. But it can't be changed. So let's decide that later on here I want to write some code, and I say that value1 equals
3.
Equals 3. That There's it is. Okay.
I was going to
say, where's my red squiggly? It's going to say that's a read-only value, and you can't change it. But you can see that it's different for every instantiation of the class. That's different than what we would expect for a const. So if I bring a const, which is value 2, I'm going to need to set that equal to something.
And you can't set that in the constructor. It has to be set up
there. It has to be set up there, and it has to be set to something that is determinable at compile time.
Yeah.
So if I set this equal to 400, that value 2 is going to be 400 no matter what.
Globally. I think of it as there's 12 months in the year, and that'll never change no matter where you go.
Right.
That's a const to me.
And you'll see when I come in here and go a dot, there is no value 2 listed. And that is because all read-only variables are just regular variables, but consts are always static. Always, 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 which means they're tied to the type and not to the actual instantiation. So a dot value 2 doesn't exist.
But some class?
But some class dot value 2 does.
Yep.
And if I was, Microsoft guru that controlled the universe, I would say that when you make a constant, you would have to tell it that it was static. Require that. Instead, it just freaks out and it knows you can't do that. But just know that all constants are static. That it's always tied to the class, not the actual instantiation. Which makes sense because it's not like every instantiation has a copy of this. There's only one copy in memory, and it's global, like you said. It's tied to the class, not each individual instantiation.
Yep.
So yeah, I think we pretty well got that one covered.
I think that's it. I don't think there's anything left.
Yeah, unless I really want to go into the weeds, but I think we got that one covered.
Yeah, I think we got that one covered too.
Thank you for watching that video from F12 Programming. Please remember to like and subscribe. That does so much for us in the ratings. You have no idea. Also, don't forget to comment below. I hope you enjoyed, and good luck coding.